I'm going to teach you guys how to size gas pipe in about 5 or 10 minutes here. So, first thing I want you to do is take a look. And everybody do this for me. You kind of need to see this. Look at the next 4 pages. Just glance, look at the next page, glance, look at the next page, glance, look at the next page, glance. Everybody do that. Do you agree at a glance every one of these tables look identical? Yep. Now, let's go back to 216. Look at the very top. What's the rule? Never look at a table till you first what? Read the name. Do you agree this is Schedule 40 metallic gas pipe? Agreed? What else do we have here? Top right. What kind of gas am I conveying through this Schedule 40? Natural. What is my inlet pressure? Less than 2 psi. And what is my pressure drop? 0.5 inch water column. Is that right? Now, real quick, let's look at 217. Just look on page 217. Are you still Schedule 40 metallic? Yep. Are you still natural gas? Yep. Are you still less than 2 psi inlet pressure? Yep. Are you still a 0.5 inch water column? Nope. Do you see the difference between those two? Now, by the way, if you go a couple of more pages, you're going to find corrugated stainless steel tube, and you're going to find plastic gas pipe and whatever, right? So again, you'll use the table and, of course, whatever pipe material they give you. If you're Schedule 40, again, we got a couple of pages of those, depending on what the pressure drop is. Again, they'd have to tell you that. Now, they have to tell you one of two things. They either have to define this table to you. Hey, when installing Schedule 40 metallic gas pipe conveying natural gas with inlet pressure less than 2 psi with a pressure drop of 0.5 inch water column. Do you agree that tells me this table? Yes. Or they could say, in accordance to table 1316.2 number 1. Yep. Right? So on the exam, they've got to give me either the data I need to get to the right table or a table number to know where to go. Okay? Test is very fair. As long as I've been teaching this, almost 30 years, this first table is the one they use every time. But do you agree they could use a different one? By the way, this is natural gas. If you go a little bit further back, even further than what we just went, you're going to find Schedule 40 propane. Right? So again, no big deal, just they got to tell me that. And once I know which table, all the tables are going to work the same. Okay? All right, so I'm going to draw a design up here on the board. I've got my meter, and I'm just going to draw a system like this. On the end, I've got an appliance. I've got an appliance over here, an appliance down here, and an appliance here, right? So, according to this illustration, the appliance on the left there is a 200,000 BTU appliance. The appliance on the right's a 400,000. On the bottom is a 400,000 BTU appliance. On the right middle, 300,000 BTU, and on the end is 500,000 BTUs. Now, what did I tell you the test tells us? For the purposes of the exam, 1 cubic foot of gas equals 1,000 BTUs. Agreed? So do you agree that 200,000 BTUs would be equivalent to 200 cubic foot of gas? Is that right? Yep. And then 400 cubic foot would be 400 cubic foot of gas, and 300,000 BTUs would be 300 cubic foot. 500,000 BTUs would be 500 cubic foot. Now again, in the real world, we would have to call the gas supplier and say, hey, what quality of gas are you delivering here? Now let me ask you another question. We're going to back away from this for just a second. Let me ask you another question. If you were in the real world and the gas company didn't know what quality of gas, and we know now that natural gas varies between 900 and 1,100 BTUs per cubic foot. If you didn't know, you would size your pipe based on what quality of gas? 900, 1,000, or 1,100 BTUs per cubic foot. 900. Why 900? Because it's the worst. Do you agree? If you give me a gas pipe big enough to give me enough gas at 900 BTUs per cubic foot, at 1,000 and 1,100, the equipment will still work. Agreed? Then I can put an orifice restricting that down at the end of the line, whatever. But if you size it on 1,100 and I'm only giving you 900, do you agree there'll never be enough gas there for that appliance to operate properly? Yeah. So again, in the real world, that's what you'll do. On the test, they tell you that 1 cubic foot of gas equals 1,000 BTUs. Now, In the 2015 code, the last adopted code, the code changed the way they size gas pipes. Some of you guys have been in my class before. I taught you how to size gas pipe. The code's actually changed since the last time you were here, some of you. The code we used to size, look up here. We would call these the furthest run. We'd call that the developed length. And then the other ones that weren't part of the furthest run, we'd call those a branch. The code now says standard method to size gas pipe is developed length. In other words, every piece of pipe up here now, we're going to size at the furthest run from the meter. So look up here on the board at my design. Do you agree from the meter I ran 10 foot and then I branched off 6 and traveled 7 more? Do you agree I don't count the 6 because it's not part of the main? And an easy way to know that is, do you agree 7 is more than 6, right? That's why I go this way. And then I don't stop. I go over another 5 foot. I've got another appliance. And then I go over another 8 foot because that's the furthest. And then I go up another 12 foot. I don't go over 10 because 16 is further. Make sense? Simply the furthest distance. So 10 plus 7 plus 5 plus 8 plus 12 plus 16 is 58 feet developed length. Now the difference in the old code and the new code, old code being prior to 2015, they would size it all the main at 58 feet and then the branches at different sizes. The new code says, hey, use a standard method of the developed length for everything. This actually just made our life a little easier. So what that says, size every piece of pipe you see at 58 feet. Okay? Now, let's take a look at this table. Back on page 126. I'm sorry, 216. Page 216, we've got this table. Now again, we read the name, we read the description, but then we got to look a little closer. This vertical column here, that is my length in feet. And across here, this is my nominal pipe sizes, right? And then down below here, these are all, look what it says above that. Capacity in what? Capacity in what? Cubic feet of gas per hour. Do you see why we've got to convert those BTUs into cubic foot? Now, I don't want to distract you, but if they do ask you a question about propane, propane is in BTUs. The table back there on propane will say capacity in BTUs. This one says capacity in cubic foot, right? That's why we had to convert our BTUs into cubic foot, right? Divide by 1,000 per the test, okay? So now we're going to plug that data in. How far am I running? Do you agree my developed length was 58 feet? On page 216, do you see 58 in that first column? No? So it goes from 50 to 60. Do you agree we'd have to use 60? Now listen, guys, we use 60 because 50 is not enough, right? We don't round up or down, but if I'm running 58 feet, then 50 feet's not as far. I got to go to 60. If I was 61 foot, you're going to have to go to 70 because 60 is not far enough. Make sense? If I was running 61 foot, I'd have to step up to the next furthest run, right? So we're going to go across there at 60 feet, and I am, so we're going to size these one piece of pipe at a time. So I put letters up here. Do you agree pipe A? Do you agree pipe A has to feed everything? Does that make sense to you? If it doesn't get through that first pipe, if there's not enough getting through there, then something's going to starve. So I would just add all those together. 200 plus 400 plus 300 plus 500. Do you agree A is going to carry 1,400 cubic foot of gas? Is that right? 5, 8, 12, 14. Right? Now we're going to do this a step at a time. While we're here, let's go ahead and get the demands on all the pipes. Pipe B. B like boy. How many fixtures or appliances is B feeding? Do you agree the last 3? Now guys, silly rule, but I'm going to teach anyway. Don't subtract that 200, re-add what remains. The reason I tell you don't subtract the 200, what if I just added wrong the first time and got 16, and now I subtract 2 and I'm still wrong? But if I added wrong the first time and I re-add this time, 400 plus 3 is 700, plus 5 is 1,200. Now I only made that mistake once. Do you agree B like boy and C like Charlie both have the same demand? Agreed? Both those pipes are feeding those last three fixtures. So Charlie is also going to be that same 1,200. Letter D like David and E like Edward, do you agree both those pipes are feeding the last two appliances, totaling 800 cubic foot of gas?
Yes.
Agreed? D like David and E like Edward's the same pipe, right? The pipe between the 400 CFM or cubic foot appliance and the 300 cubic foot. So D like David, E like Edward are carrying those last two, 800. And then F like Frank is only carrying 500. You agree? F like Frank is only carrying that one appliance. So do you agree with what I got written up here on the board? A carries 1,400 cubic foot of gas, 58 feet. B and C both carry 1,200 cubic foot of gas, 58 feet. D and E both carry 800 cubic foot of gas, 58 feet. F carries 500 cubic foot of gas, 58 feet. Now just so you know, if you've been in this class before, you should agree with all that. That didn't change. Now here's what changed. Find me letter G like George. Do you agree that's the one pipe feeding the one appliance to the right? Do you agree the demand on G is only 300 cubic foot of gas? Agreed? Because G is only feeding this one appliance. Now the difference is, prior to 15, we would have counted the distance straight back to the meter from there. Now they're saying, hey, the standard method is use the same developed length, 58 feet. This just makes our life easier, right? So now G, H, and I are all 58 feet also. G has a demand of 300 cubic foot, H has a demand of 400 cubic foot, and I has a demand of 200 cubic foot. Everybody agree with that?
Yep.
Now we're going to go to that page 216 and we're going to size this pipe. We go down that first column. Again, we're looking for 58. We don't have a 58, so we go to the next row, 60. What is the minimum size pipe at 60 feet of run on page 216 that'll carry 1,400 cubic foot of gas?
2 inch.
Do you agree that's a 2-inch, right? So 60 feet, looking for 1,400, that's going to put me at a 2-inch. Now again, just to be clear, some people look at that and go, hold on, wait, that'll carry 1,520. Right. But the smaller one will not carry 1,400. We didn't step up to 1,520, but the smaller one there, 791, won't carry 14, so we had to step up. What about B like Boy and C like Charlie? They're actually the same, 58 feet at 1,200. So 58 feet, there's not a 58, go to 60, looking for 1,200 cubic foot of gas. Do you agree that's still a 2-inch?
Yep.
Right? Mm-hmm. What about D like David and E like Edward? Those are both 58 feet carrying 800 cubic foot of gas. Still a 2-inch. Now, by the way, we almost made it. But remember, almost is not enough. 791 will not do 800, so we had to step up to the next one. Letter F and G. 58 feet at, just F. 58 feet at 500. So 58, looking for 500, that could be 1.25 inches. G like George, 58 feet at 300. 58 feet at 300, still 1.25 inches. H like Henry, 58 feet at 400. 58 feet at 400, still 1.25 inches. And then 58 feet at 200 for I, now we can step down to a 1-inch. Do you agree the average plumber would have ran a 2-inch the whole way? Right? That's the difference in what we do in the field, which is better as opposed to what they're going to ask us on the test. For example, on a question like this, they're not going to ask you to size a design like this. They're going to say, what size is pipe C? Right? And you'll say, okay, pipe C right there is carrying those last three fixtures, 400, 300, 500, that's 1,200. The developed length, right? 10 plus 7 plus 5 plus 8 plus 12 plus 16, that's 58 feet. So now 1,200 at 58 feet, right? They'll ask you one piece of pipe at a time, okay? So you don't need to size the whole design, just wait for them to ask you. You guys okay with this? I think of all the sizing, I think gas pipe's actually one of the easiest to size. Really, the only thing you can do wrong here is be on the wrong table. Beyond that, I mean, the table's pretty self-explanatory. The only other thing you might be able to do wrong is BTUs instead of cubic foot. Because again, if I did this by BTUs, that would be 1,400,000 BTUs. Right? 1,400,000 BTUs. Let's take a look at that. I've got the table cut off there. 1,400,000 at 60 feet, right? Do you agree I'd look at that and go, I don't even go that big, right? Now I'm lost. But again, notice that 60 feet all the way across, that's 151 or 52,000 cubic foot of gas, not BTUs. Okay? You guys okay with this?
Yes, sir.
Pretty straightforward stuff, isn't it? So, again, sizing gas is pretty straightforward. A couple of steps, we go from the meter to the furthest point. The furthest point is the furthest point because it's the furthest point. That's it. Furthest run ever. And then, remember, we only measure the distance to get to the furthest point. We don't add the branches to that because the gas is not going to go in and out of I and in and out of H and in and out of G, right? It's just going to take the path of least resistance to the furthest run. And then, every piece of pipe you look at, which fixtures is this pipe alone feeding? If it's feeding one fixture, then that's your total demand. If it's feeding two fixtures, then combined, that's your demand, right? That's all there is to this. Very straightforward.